All right, so this video is going to go over the 5 types of reactions and predicting the products. So we're going to start on number 1. So 1 sodium carbonate and magnesium nitrate. So you need to make sure you have your polyatomic list and your periodic table handy so you can get charges and formulas. So sodium is a +1. Oh, let me get my pen going. +1. Carbonate is a -2. Okay, so when you put those together, they are not balanced. So sodium carbonate would look like this. So Na2CO3 plus magnesium nitrate. Okay, so magnesium is a +2, nitrate is a -1. Okay, so you're going to have 1 magnesium and 2 nitrates. Now, we got to figure out what type of reaction is this. Well, you've got 5 types. Synthesis is where you take 2 things and bring them together to make 1. Decomposition is where you take 1 thing and break it down into 2 things. Single replacement is where you have someone single in the beginning of the reaction and someone's replaced and now someone's single in the end. A double replacement is when you have 2 pairs and they just swap partners. And combustion is when you have a hydrocarbon reacting with oxygen to make CO2 and water. So if you notice, I have 2 pairs here. Okay, so this is going to be a double replacement. Now, all you're going to do is a partner swap. This sodium is going to go with this nitrate, and this carbonate is going to go with this magnesium. Now, when you do that, you need to make sure you still balance based on charge. So sodium is a +1, nitrate's a -1, so that's going to be NaNO3. They're already balanced. Plus magnesium and carbonate, +2, -2, it's already balanced, so this would be MgCO3. Okay, so now I'm done writing it. I just got to make sure I'm balanced. Okay, if you look on the left, I have 2 sodiums, 2 Nas, but only 1 sodium on the right. So I'm going to put a big 2 in front of this. Now that 2 is going to affect both this sodium and this nitrate. Okay, so now my nitrates, I have 2 of them. But if you look here, I've got 2 nitrates right there. So that balances out that. 1 magnesium on both sides and 1 carbonate on both sides. So that means all I had to do is just put that 2 right there and it's good. All right, number 2, ethanol liquid. Okay, so that literally is ethanol, C2H5OH. Burns in the presence of oxygen. So you're adding oxygen to it. Okay, and this is going to be a combustion. Okay, you're reacting with oxygen to make CO2 and H2O. Okay, for combustion, I usually like to do the CHO to keep things tallied. So I got 2 carbons on the left, 6 hydrogens on the left, so they're separated, and 3 oxygens on the left. On the right, I've got 1 carbon, 2 hydrogens, and 3 oxygens. So I need to get to 2 carbons on the right, so I'm going to put a 2 in front of CO2. Okay, I'm going to fix that carbon, but I'm going to recount my oxygens. So I got 2 times 2 is 4, plus the 1 on the H2O, that gives me 5. Then I'm going to go to hydrogen. I need 6 on the right, only have 2. So I'm going to put a 3 in front of the H2O. That gives me 6. Now I'm going to recount what I have. 2 times 2 is 4, plus 3, I now have 7 oxygens. So if you look on the left, the last thing I want to do is put anything on that ethanol because then you just start over. So this oxygen right here is staying put. So I want to figure out how can I manipulate this O2 to get me to 7. So 1 plus what would give me 7? Well, that would be 6. So I'm going to multiply this by 3. So now I recount my oxygens and I have 7 on the left. And now it is balanced. 3, sulfurous acid and magnesium hydroxide. So remember, acids always start with an H. Okay, hydro means no O. I don't see any hydro, so that means we're dealing with oxygen. So sulfurous would be sulfite. So that's SO3 with a -2. Okay, so my formula would be H2SO3. Plus magnesium hydroxide, +2 and a -1. So that would be MgOH2. Okay, well, if I look, I have a pair and a pair. So this is just going to be a partner swap. So this is a double replacement. Okay, so hydrogen's now going to go with OH. And you're going to get H2O. Because that's what happens when you mix an acid and a base. You get water and a salt. And magnesium's going to go with sulfite. Okay, so this is going to be MgSO3. They're already balanced. It's a +2, -2, so I don't need to do anything there. Okay, so if I need to count, okay, I'm going to check. I have H2, so I'm going to balance it out. Now, on here, you see how you have H and OH split up over here? So when you balance it, you can actually change this H2O to an HOH. Okay, that can kind of help keep things kind of balanced. So I have H's to balance, I have SO3s to balance, I have magnesiums, and I have hydroxides. So on the left, I've got 2 hydrogens, 1 sulfite, 1 magnesium, and 2 hydroxides. On the right, I got 1 H, 1 OH, 1 magnesium, and 1 sulfite. So I need to get to 2 hydrogens on the right, so all I got to do is put a 2 in front of this HOH, and that fixes my H and my OH at the same time, and it's already balanced. Number 4, nitric acid and sodium acetate. So nitric acid, acids always start with a hydrogen. There's no hydro, so I know I'm dealing with oxygen here. So nitric would be nitrate. So that's NO3 with a -1. Okay, so this would be HNO3 plus sodium acetate. So that's a +1 and -1. So this is just going to be NaC2H3O2. This is going to be another double replacement. I have 2 pairs, so we're going to swap partners. So H is going to go with acetate, so this is going to give me HC2H3O2. And now sodium is going to go with nitrate, so I'm going to get NaNO3. And they were all +1, -1, so this was just a simple partner swap, so everything's already balanced, so this one's already done. Okay, number 5, heating solid calcium carbonate. Calcium's a +2, carbonate's a -2, so this would be CaCO3. Now when you add heat, we got to add a little triangle above that arrow because that means we added heat. We're not burning it, we're just adding heat. And if I only have one thing, the only thing it can do is break down. So this is going to be decomposition. Now when it comes to decomposition, when you're dealing with a polyatomic like that, when you're dealing with oxygens, remember we talked about you had 3 draft picks on what you would try to make. 1 would be, can you make H2O? That would be your number 1 shot. 2 is, if you can't make that, can you make CO2? If you can't make that, last one is O2. Okay, so I definitely can't make H2O. And I do have CO3, so I can make
Here's some information.
I can see CO2. So I'm going to make CO2. But calcium is going to be a little bit clingy, and it's going to hold on to that last oxygen. It's not going to let everything go. Okay, so now in this case, it is already balanced, so this one is already done. Zinc solid and silver nitrate solution. So zinc is a +2, and we're just going to put zinc. Plus silver nitrate, so silver is a +1, nitrate's a -1, so this would be AgNO3. Okay, so now if you notice, I have zinc by itself, and you have a pair of Ag and NO3. So actually, this is going to be a single replacement. So zinc is trying to replace silver. Okay, a positive can only take a positive's place, and a negative can only take a negative's place. So in this case, zinc is trying to take silver's place, so nitrate has to choose, is zinc better? Okay, so we're going to go down to our activity series that we give you. Okay, so right here. Okay, that is your activity series for metals. So this is where it tells you if something's better. Okay, so if I look, zinc is right here, and silver is way down here. So zinc is a lot better. So in this case, silver is going to get dumped. So silver's off on its own. And zinc is now going to go with nitrate. Okay, so remember, zinc is a +2, nitrate's a -1. So this is going to be ZnNO3 2. So now I got to see, is it balanced? I have 1 zinc on the left, 1 zinc on the right, 1 silver on the left, 1 silver on the right. I've got 1 nitrate on the left and 2 on the right. Okay, so I need to get to 2 nitrates on the left. So I'm going to put a 2 in front of this AgNO3. Okay, now that affects my Ag2, so now I got to fix my Ag on the right. And now I'm done. 7, heating solid sodium chlorate. Okay, so sodium's a +1, chlorate's a -1, so it's going to be NaClO3. Okay, and we're adding heat to it. It's only one thing, so all it can do is break down, so this is decomposition. So remember your draft picks up here. I can't make H2O, I can't make CO2, so I can make O2. Now here's the kicker about O2 is if you're down to your last draft pick and you're making oxygen, all the oxygen's gone. Okay, so if that O2 is leaving, every oxygen's going with it. So don't get hung up that there's 3 on the left and there's 2 on the right. You do not need to use all 3 at once. Okay, we can balance it later. Okay, so oxygen is gone. So sodium's actually going to hold on to that last chlorine. Okay, so sodium is a +1, chlorine's a -1, so this would just be NaCl. So I've got to look at how do I balance it now. I've got 3 oxygens on the left, 2 on the right. So the only way I can do that is I need to get them to the closest number divided by both 3 and 2, which would be 6. So I'm going to multiply this whole NaClO3 by 2. And I'm going to multiply this oxygen by 3 to get to 6. Now when I did that, it affected my NaCl. So I'm just going to put a 2 right there to fix that. And now it's balanced. Number 8, calcium metal. So calcium is Ca. It's a +2. Plus steam. Steam is just H2O, but it's just in the gas form. Okay, so I don't even have to really put anything there. I'm just going to put H2O. Now, you've got something alone. Okay, so calcium is going to go and try to replace hydrogen. This is a single replacement. Okay, so it is not synthesis. Okay, so our synthesis rules are 1, can you make hydroxide? Okay, and 2, can you make CO3 or ClO3? Okay, so I definitely can't make CO3. I can't make ClO3. The possibility of a hydroxide, but usually I'll tell you what's going to happen is it would have to be a CaO, a calcium oxide, to be mixed with that in order to make calcium hydroxide. Okay, so once you kind of start seeing those, you'll start to kind of get that pattern, and they all start looking the same. So this is a single replacement. So oxygen's got to choose, is calcium better? So we're going to go down here on our activities. Activity series, calcium's right here. Hydrogen's down here. So, yep, hydrogen's going to get dumped. Now, don't forget Brinkelhoff is when that hydrogen gets dumped off, it has to be an H2. So remember, Brinkelhoff is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. If they are not paired up with another element, okay, they have to run in pairs. So it has to be H2. And now calcium is going to go with oxygen. Oxygen is a -2, so this is going to be just CaO. So you got to see, is it balanced? 1 Ca, 1 Ca, 2 H's, 2 H's, 1 O, 1 O. Yep, it's already balanced. So this one's done. Bromine liquid. So bromine's a -1. Remember, bromine is a part of Brinkelhoff. So that is Br2. And potassium iodide. Potassium's a +1. Iodine's a -1. So this would just be Ki. Now, you've got bromine off by itself. Okay, so this is going to be a single replacement. But in this case, you have a negative trying to take a negative's place. And if you look on that activity series, you're not going to find bromine or iodine on that list at all because this list is for metals or cations. Okay, so if you're going a negative and a negative, what you want to do is you want to use the periodic table the same way. Okay, the higher it is, the better it is. Okay, so we got to figure out, is bromine higher than iodine? So we go back down here. Okay, bromine's right here, iodine's right here. Yep, so bromine is going to be better. So this case, iodine's going to get dumped. It is a part of Brinkelhoff, so it needs to be an I2. And now K is going to go with bromine. So this is just going to be KBr. So you got to see, is it balanced? It is not. I've got 2 BRs on the left, only 1 on the right. So I'm going to put a 2 on that KBr. Okay, now my potassiums are off. So I need to get 2 Ks on the left. So I'm going to put a 2 right there. And now that fixed both my Ks and my Is. Number 10, aluminum metal and fluorine gas. Okay, aluminum is a +3. Fluorine is a -1. So aluminum is just aluminum. Plus fluorine gas, so that's Brinkelhoff, so it has to be F2. All right, so I only have 2 elements. Okay, so the only thing I can do is there's no swapping involved, so all I can do is just put them together. So this would be synthesis. So when you do put them together, they need to be balanced based on charge. So this would be AlF3. Now I can balance. Okay, so I've got two F's on the right. I'm sorry, two F's on the left, three F's on the right. So I need to get them both to 6. So I'm going to put a 3 on this F2. I'm going to put a 2 on this AlF3. But now that messed up my aluminums. So now I got to put a 2 up here, and now that one's done. Okay. I'm going to kind of jump around a little bit and see if I can find some more interesting ones. All right, so number 14, solid magnesium oxide. Okay, so Mg is a +2, oxygen's a -2. So this would just be MgO. Plus, water is just H2O. Now, this could look like a double replacement, but switching the oxygens wouldn't do you any good. It would just look the exact same. So this is actually going to be a synthesis problem. So your synthesis draft picks, we kind of talked about that, was OH. Can you make hydroxide? If you can't do that, can you make a polyatomic like CO3 or ClO3? So in this case, I can make hydroxide. So I'm going to make magnesium hydroxide. So remember, magnesium's a +2. Hydroxide's a -1. So this is going to be, I need 2 of these hydroxides to be balanced out. Okay, so those charges aren't my answer. I'm just showing you how I balanced it the way I did. So I'm going to check, is it balanced? 1 magnesium, 2 O's, 2 O's, 2 H's, 2 H's. So it's already done. Number 15, I have C4H9OH plus O2. This is definitely going to be combustion. So I'm going to go ahead and just put CO2 plus H2O. I already have the formula written down, so I don't need to really do it. Don't need to really repeat it again. So I'm going to balance it. So I got CH and O. On the left, I got 4 carbons. I've got 10 hydrogens and 3 oxygens. On the right, I got 1, 2, 3. So I need 4 carbons on the right. So I'm going to put a 4 in front of CO2. That fixes my carbons. I'm going to recount my oxygens. 4 times 2 is 8 plus 1 gives me 9. Now I need 5 hydrogens. So don't chase that rabbit. Don't go straight for the oxygens. Just go ahead and keep going down the list. So hydrogens I need to get to 10. So I'm going to put a 5 on that H2O. That'll get that to 10. I'm going to recount my oxygens. 4 times 2 is 8 plus 5 now gives me 13. So now I got to get to 13 on the left. So remember, last thing I want to do is touch that compound right there because you just start all over. But this oxygen is there, so don't forget it's there. So 1 plus what would give me 13? That'd be 12. So all I got to do is just multiply this O2 by 6. And now I have 13. So that one's done. All right, so let's look. The next one, I have aluminum and lithium chloride. So aluminum is a +3, and this is just aluminum, so I'm just going to put aluminum. Plus lithium chloride. Lithium's a +1, chlorine's a -1, so this is just going to be LiCl. So I've got aluminum off by itself. Okay, so this is going to be a single replacement. So aluminum is trying to take lithium's spot, so you got to go down to your list. Is aluminum higher than lithium? So we're going to look here. Oops. Let me erase some of these. Oops. All right, so lithium is pretty much top dog. Okay, so nothing is above it. Even though aluminum's pretty high, lithium is the best one on there. So if you're already with the best, you're not going to leave the best for someone worse. Okay, so if aluminum is lower on that list, you're not going to replace it with something worse. So nothing's going to happen. So you're just going to write no reaction. Okay, so again, on a single replacement, if it is not higher either on the periodic table or on that list, it's going to be a no reaction and nothing's going to happen. All right, so number 19, aluminum metal and hydrochloric acid. Okay, so aluminum is a +3, and it's just aluminum, so Al. Hydrochloric acid, hydro means no O, so we're going to deal with just H, and chlorine, which would be Cl. So this would be HCl. So I have aluminum off by itself, so this is going to be a single replacement. So now you got to figure out, is aluminum higher than hydrogen? So go back down to our list. Okay, aluminum is right here. Hydrogen is down here. Yep. So this is going to be replaced. So hydrogen is getting dumped, so it's going to be H2 because of Brinkelhoff. And now aluminum is going to be with chlorine, so just pay attention to your charge. You have a +3 and a -1, so there's going to be AlCl3. So now I'm going to balance. I got 1 aluminum, 1 aluminum, 1 H, 2 H's. Okay, so if I put a 2 here, okay, that'll fix the H's. But now I got 2 Cl's and 3 chlorines. I'm sorry, 3 Cl's on the right. So don't think that just because you put something on HCl, it's set in stone. Okay, so what I'm going to do is, in this case, I can't do a 2 and I can't do a 3, so I know I need to probably get to 6. Okay, so I'm going to go ahead and multiply this AlCl3 by 2 to get that chlorine to 6. And then I can just get rid of that 2 on the HCl and just put a 6 there. Okay, so that gets my chlorines. Good. Now my aluminums are off and my hydrogens are off. Okay, so it doesn't matter which one we're going to do right now. So I've got 2 aluminums on the right, so I'm just going to put a 2 in front of this Al. So that fixes the aluminums. They're good. So my aluminums are good. My chlorines are good. Now my H's, I have 6 hydrogens on the left. I have 2 on the right. So I'm just going to put a 3 on that H2. And now that one's done. Okay, moving on to number 20, calcium hydroxide and nitric acid. Calcium's a +2. Hydroxide's a -1. Okay, nitric acid. Okay, that's going to be an H+. Nitric means nitrate, and there is no hydro, so I know I'm dealing with nitrate, so that's -1, NO3 with a -1. So calcium hydroxide looks like this, CaOH2 plus HNO3. All right, so I've got 2 pairs, so we're going to be doing a partner swap, so it's going to be double replacement. So calcium's going to go with nitrate, so calcium's a +2. Nitrate's a -1, so I need 2 nitrates. Plus, H and OH are going to go together, so we're going to make H2O. So I'm going to balance it out. So I'm going to go ahead, since I have H and OH split up over on the left side, I'm going to change this H2O to an HOH. So I'm going to look at it. So I've got 1 calcium on the left, 1 calcium on the right, so I'm good there. I've got 2 OHs on the left, only 1 on the right, so I'm going to put a 2 in front of the HOH. Okay, now what that does is my OHs are good, but now my H's are off. I have 1 H on the left, 2 H's on the right. So I'm going to put a 2 in front of this HNO3. So that fixes my H's, but it also changes my NO3s to 2. So it's affecting this as well. And now both my nitrates are balanced on both sides. So that one's good to go. Let's see if I can find another one. 22, sodium iodide solution in aqueous bromine. Okay, so sodium's a +1, iodine's a -1, so this would be NaI. Plus bromine, and that's Brinkelhoff, so it's Br2. So in this case, bromine is a -1. So you have bromine trying to take iodine's place. You have to see, is bromine higher than iodine? Yes, it is. Okay, so look on the periodic table and see which one's higher. So iodine's getting dumped. It's part of Brinkelhoff, so you got to put I2. And now sodium's with bromine, so it's going to be NaBr. So I'm going to see if it's a balance. So I got 1 Na on the left, 1 A on the right, so that's good. 1 I on the left, 2 I's on the right. So I'm going to put a 2 in front of this NaI. But that just changed my NAs. So I have 2 NAs on the left, 1 on the right. So I'm going to put a 2 on that NaBr. So now that fixes my NAs, and it also fixed my Br. So now I am good. Okay, so let's see. Let's look for another one. We'll do number 25, solid zinc carbonate. Okay, so I have zinc is a +2, carbonate's a -2. Okay, so this would be ZnCO3 is heated. So I'm going to add that little triangle. So this is decomposition. Okay, so remember your draft picks is H2O, CO2, and O2. Okay, in this case, I can make CO2, and zinc's going to hold on to that last oxygen. So it's going to be ZNO. And it's already balanced, so that one's good to go. Number 26. Okay, I have solid barium oxide. Okay, Ba is a +2. Okay, and then oxygen's a -2. So this is going to be BaO plus H2O. Okay, which is water. So in this case, it looks like a double replacement, but switching oxygens wouldn't do me any good. It's not decomposition, it's not combustion, it's not single replacement, so it has to be synthesis. So remember, your draft picks for synthesis is, can you make hydroxide or can you make a polyatomic like one of these two? So in this case, I can make a hydroxide. So barium is a +2. Hydroxide's a -1. So I need 2 of them. Now if I check, everything's already balanced. So this one is good to go. Let's scroll down a little bit. I'll go ahead and pick number 31. Solid tin. Okay, and mercury 2 nitrate. Okay, so in this case, I'll go ahead and tell you, normally what we would do is we'd give you the charge. Okay, in this case, tin is going to be a +4. Okay, and mercury 2 nitrate, so tin is SN by itself. Mercury 2, that tells me the charge of mercury is a 2, and nitrate's a -1. So mercury is Hg. So I need 2 of these nitrates to balance out. So I have tin off by itself, so it's going to be a single replacement. Okay, so I got to look on the list. Is tin better than mercury? So I'm going to go down here. Okay, tin's right here. Okay, mercury's down here. So yep. So mercury's going to get dumped. It is not a part of Brinkelhoff, so you do not need 2 of them. Okay, so Hg is off on its own, and now tin is going to go with nitrate. So tin is a +4, nitrate's a -1, so this is going to be SnNO3 4. Okay, so I know this is not balanced. Okay, what I need to fix is my nitrates. I've got 4 on the right, 2 on the left, so I'm going to put a 2 on that HgNO3 2. That fixes the nitrates, but now my Hg's are off, so I'm going to put a 2 on the Hg on the right, and now I'm good. Okay, so I'm going to look at, let's see, 32. Potassium metal. So potassium is a +1, and it's just by itself. Sodium is a +1, nitrate's a -1. So this is going to be NaNO3. So this is going to be a single replacement. So potassium is going to try to replace sodium. So if you look on that list, potassium is higher on the list, so sodium's going to get dumped. And now potassium is going to go with NO3. They're both a +1, -1. So this is going to be KNO3. It's already balanced. It's good to go. So that one does not need much. Let's see. Number 34. We'll do this last one. Combustion of liquid octane would be C8H18. So C8H18 plus oxygen gas. So O2 is going to give me CO2 and H2O. So this is combustion. So I'm going to go ahead and do my CHO. On the left, I got 8 carbons, 18 hydrogens, and 2 oxygens. On the right, I got 1 carbon, 2 hydrogens, and 3 oxygens. So I'm going to start with carbons. I need to get to 8, so I'm going to put an 8 on that CO2. That fixes my carbons. I'm going to recount my oxygens. 8 times 2 is 16, plus 1 is 17. Now I need to go to hydrogens. I need 18 on the right, so I'm going to put a 9 on that H2O. So 9 times 2 gives me 18. I'm going to recount my oxygens. 8 times 2 is 16, plus 9 gives me 25. So I need to figure out what can I multiply this by to get to 25. So this is called the decimal trick. Is 12.5 would get you there. Okay, so go ahead and write it down. Now a decimal, I cannot keep it. I cannot have 12.5 oxygens. So I need to have a whole number. So the way we fix that is we're going to double it. So that 12.5 becomes a 25. Okay, but when you do that, you double everything. So this 1 that was on C8H18 now becomes a 2. The 8 on CO2 becomes a 16. And the 9 on hydrogen becomes an 18. So if you want to check, carbons on the left, now you got 16 carbons on the left, 2 times 8. On the left, 2 times 18 hydrogens is 36. And then on the left, you got 50 oxygens. On the right, 16 times 1 gives you 16 carbons. 16 times 2 is 32, plus 18 oxygens on that H2O is going to give you 50. And then 18 times 2 is going to give you 36 hydrogens. Okay, so it does match out. Okay, so hopefully those examples kind of helped you out a little bit. I know I didn't cover all of them, but I tried to cover all the possible types of problems. So let us know if you have any questions.